Hello and welcome to this video on passive transport. So in the previous video we discussed the fact that the cell membrane can control what goes in and out. So in the next couple we're going to go ahead and discuss how this happens. The first way this works, how things can go from the inside to the outside or outside to inside, is called passive transport. So osmosis and diffusion. I want you to go ahead and think of passive transport like going with the flow down a river. So passive transport. Passive transport is the movement of molecules through a cell membrane that does not use energy. And the materials will often move from an area of high concentration to an area of low concentration. So if we go ahead and look at these three here, we have slide 1, we have part 2, and we have part 3. So in the beginning, we have more of these molecules on the outside of the cell than we do the inside. And over time, what you can see here is it's moving from where we have a higher concentration to where we have a lower concentration. And this is going to continue until we roughly have an equal amount on both sides. So over time, it'll gradually move until balance is achieved. Diffusion. Diffusion, simply put, is the movement of molecules through a cell membrane. And remember, it's always going to move from where there is more to where there is less. So it's going to move from where you have a high concentration to where you have a low concentration. So, if we go ahead and take a look here, which direction do you think the molecules are going to move? Is it going to be from A to B or B to A? Right on, if you went ahead and said from A to B, well done. So, considering there's more on the left side than the right, the molecules will gradually go ahead and move from the left to the right over time, from A to B. Now this is continued until equilibrium is reached. Now, equilibrium is reached when concentrations are equal on both sides of the cell membrane. So, at this point, the movement of materials does not stop. But what happens is we have an equal amount going inside the cell and outside the cell. So we have an equal rate of in and out. So that way it still maintains balance while the materials are moving. So we discussed diffusion, which is the movement of molecules across the cell membrane. Now we're going to discuss osmosis. So osmosis, simply put, is the diffusion of water through a cell membrane. Now water is always going to diffuse from an area of low solute concentration to an area of high solute concentration. So what we mean by that is wherever the most solute is, so salt, sugar, or molecules, the water will move to that area to try and go ahead and balance things out. It's all about ratios. It wants an equal amount of water as compared to the solute. So, if you take a look up here, on the left-hand side, we don't really have a lot of salt, but on the right-hand side, we have a lot. So what's going to happen here is the water will gradually go ahead and move from the left to the right to try and go ahead and balance out the ratio of water to salt. Now another way to look at this is the water is always going to move from where there is more to where there is less. So if you take a look, this goes ahead and further drives home the point. On the left-hand side, we have more water than solute, where on the right-hand side, we have more solute than water. So considering we have more water on the left-hand side than we do the right, the water will move from the left to the right. Now, considering that we know with osmosis, water moves from an area of high concentration to low concentration, or an area of low solute to high solute, we have different types of solutions which are going to influence how this water moves. So in a hypotonic solution, we have a low solute concentration on the outside and a high solute concentration on the inside. So if we have a low solute, that means we have high water. And on the inside, we have a high solute, meaning we have low water. So the water isn't happy. It's going to go ahead and try to balance this out on the inside and outside. So in a hypotonic solution, there is more solute inside the cell than outside the cell. So hypo means more. So at this point, water is going to move into the cell, causing the cell to go ahead and swell up. So hypo, my apologies from what I said earlier, hypo means low or below normal. So there's a low amount of solute concentration on the outside and a high amount on the inside. The point here is hypo means water moves in and the cell expands. Now hypertonic solutions, on the other hand, are a little bit different. So hyper, there's a high solute concentration on the outside, so high solute means low water, and we have a low solute concentration on the inside. So we have a high amount of water. So considering what we know, water wants to move from where there is low solute to high solute, or high water to low water, so water will go ahead and move out of the cell. So a hypertonic means there's a higher solute concentration on the outside than the inside, so the water will move out of the cell. Now hyper means excessive, so we have more solute on the outside. Now this is going to go ahead and cause the cell to shrivel up. Finally, we have isotonic solutions. So iso means equal. So in an isotonic solution, the solute concentration is equal on both sides of the cell membrane. So considering that it's equal, what's going to happen here is we're going to have an equal amount of water going in and out at the same time. So if you go ahead and take a look, right here, we have water going in and water going out at the same rate. This is going to go ahead and cause the cell to stay the same size. So isotonic, animal cells love isotonic solutions. Now osmosis and plant cells, however. So plant cells love a hypotonic environment. Now remember, in hypo, water moves in. Now this is important because, remember, plant cells have a very large vacuole which is used for storing water. So when that vacuole is filled with water, the plant cell is happy, hence why it likes hypotonic. It wants water to go into its cells. So plant cells require a hypotonic environment so water moves in. The swelling of the cell is called turgor pressure. Now, however, if a plant cell is in a hypertonic environment, it's going to go ahead and lose water and shrivel up. The plant cell doesn't really like this. Plants don't normally like to be shriveled up, and if you think about it, if you forget to water a plant, this is exactly what happens. It starts to go ahead, shrivel up, and die. This is called plasmolysis. So the last thing we need to discuss is facilitated diffusion, or assisted diffusion. So facilitated diffusion is the movement of molecules in and out of the cell, still going from a high to low concentration, but this time you're using a carrier protein to help you. So why would molecules need help from a carrier protein? Well, simply put, if the molecule was too big to diffuse through the cell membrane, or it has a charge on it, it can't get through. Or it could not go ahead and dissolve through the phospholipid bilayer, so it actively couldn't diffuse, so it needs a little help getting in. Now finally, we have a quick review here. If you remember, what happens to a cell in the following situations? You can go ahead, pause, figure out your answer, then unpause, and check to see if you're right. So an animal cell in a hypertonic solution, remember hyper, water leaves, so the cell would shrivel up. In an isotonic solution, the animal cell likes this, so it's going to stay the same size as water goes in and out evenly. In a hypotonic solution, water is going to rush into the cell, causing it to swell and eventually explode. That's not good. In a hypertonic solution in a plant cell, same thing happens. It shrivels up, or goes through plasmolysis. In an isotonic solution, there's some water in there, but not nearly enough to keep the plant happy. So we call this flaccid. It's not what the plant cell wants. And finally, a hypotonic solution, water rushes in and causes the cell to swell up, causing the plant to go ahead and stand straight up and down. This is what the plant cell likes. So this right here goes ahead and closes up shop on this video regarding passive transport. If you have any questions, please feel free to go ahead and contact your instructor. Thank you very much for your time, and until the next video, you take care of yourself.